So now using this template that I created, we're going to make a key together and comp our character into a new environment. First of all, we're going to start with the prep section. This consists of denoising our plate, but also removing unwanted elements from our footage, such as tracking markers, mic booms, or reflections of camera crew, etc, etc. Let's start with the denoise. As we said in the basic overview, the denoise takes care of getting rid of the grain in our footage. To do this, press Tab on your keyboard, then type denoise. Then attach the source to our plate. As you can see in the bottom left corner of your plate, there's a small box which appears. It's the sample box. This is what's going to take care of sampling the grain from the footage, but we need to find a nice smooth and flat area to sample from. Preferably we want to find somewhere near our character, as this is the only part of the footage we are going to keep. Unfortunately, in this shot there isn't any flat area nearby. Also, what we would like to do is find an area which isn't too bright, as there tends to be more noise in the dark areas. The only area I could find which was flat was in the sky. This section seemed the darkest, so I'm going to sample from here. Now we're going to drag our sample box to cover as much of the flat area as possible. If you gamma down in your viewer, you can see the denoise is removing all the noise from the plate. We could even increase it to 2, and that's doing an even better job. But we really want to see how it's affecting our character, as this is the element we're going to keep. If we look at the face, we can see that I'm removing too much noise because we're losing a lot of detail in our character, especially in the hair. I'm going to reduce it back to 1 to bring back more details. Now we can move on to the next step in our prep. This is the cleanup section. In this case, we're removing tracking markers because during the shot the character will intersect with them. This is going to interfere with keying, especially here. We have this marker which is going to be reintroduced in comp if we do not remove it. Here we have a very good tutorial by Alfie Vaughan on how to remove unwanted elements from your shot. You can find it on our Foundry Learn page. There's a link right here if you want to copy it. It will also be available in the description of the video. We're now going to move on to the screen clean section. So if you just remember what a screen clean does, is it removes all the wrinkles and lighting variations across our green screen. So if we compare between before and after, you can see it's doing a fantastic job at removing this, making our plate a lot easier to key. Essentially what we're doing is we're dividing our plate, which has our character, by a recreation of a plate without the character through a merge node. And what that's doing is it's flattening out all our creases, lighting variations, and all the details which we want to remove out of our green screen. Lastly, we're bringing back the green screen color with a grade by sampling it from the original plate. So now let's recreate this setup together. The first step is to recreate the green screen background without the character. With this, we are essentially telling the merge divide operation what to remove from our green screen. Firstly, create an IBK color. You can do this by pressing Tab on your keyboard and then type IBK and then select it from the drop down menu. Then let's attach it to the beginning of our setup, and then in the properties of the IBK color, we're going to change our screen type to green as we have a green screen. If you have a blue screen, then you change it to blue. The next step is to change the size to a lower number, such as 1. We are changing it to a lower value to keep all the details and creases in our green screen. If we look at our IBK color, as you can see, if I start increasing the size, it's going to blur all the creases and details out. And remember, by recreating the green screen background without the character, we are telling the merge divide operation what to remove. So if we blur the creases out of the green screen, then we are telling the merge divide operation to keep them, and we don't want that. So we want our green screen to be as accurate as possible. Then we're going to start modifying the darks and lights in the RGB values. This will enable us to retrieve all this green screen information over here that wasn't picked up by the initial setup. However, when retrieving this information, we want to make sure we're not reintroducing bits of the character back. To tweak these values, you can either click on the knob which you want to modify and then scroll up and down with the middle mouse button, or you can press on the up and down arrows on your keyboard, but I prefer to use the color wheel. If we click on it, you have some sliders which you can adjust. So I'm now going to tweak these values one by one over the next few minutes. As you can see, this is looking much better. The only problem is we've still got some information that's being brought back from within the character. So I'm just going to keep on adjusting until this disappears. The values brought back are quite dark, so I need to tweak in the dark section. If you make a mistake, you can press Ctrl and click on your left mouse button to bring back the slider to its default settings. Another way to check you're not bringing back anything in the character is to bring down the gamma slider or the exposure slider in the viewer. Also, we do not need to worry about reintroducing elements from outside of the green screen, as this will be removed later on with a key called garbage mat. Now that we've got a very good green screen, the next step is to copy the IBK color that we've just made and paste it underneath the previous one. So Ctrl C and Ctrl V. But in this IBK color, we're going to adjust this setting over here called Patch Black. This is going to stretch our pixels on the border inwards, recreating what the green screen would look like if the character wasn't present. I usually start with a very low number, as if you start with a high number, the stretching will cause the border of your green screen to be blurred. You can see if I deactivate and reactivate the IBK color, you can see it's blurring the border too much. That's why I start with a very low number, as it doesn't blur as much. We're also encountering another issue. Our IBK color is reintroducing a dark edge from our character. We can fix this by going back to our first IBK color and increasing the erode until the dark edge disappears. Now if we go back to our second IBK color, we can duplicate it again, and I'm just progressively increasing the patch black, one IBK at a time, in order to not soften the surrounding green screen. We're going to keep repeating this procedure of duplicating the IBK and increasing the patch black until we fill in all of the black that's left. Now that that's done, let's create a merge node. You can do this by pressing M on your keyboard, and if you have the last IBK color selected, it will create the merge right underneath it. Let's attach the A to our source and view our merge. We can see it's not really doing anything presently. That's because we need to change the operation to divide. Now let's create a grade node. You can do this by pressing G on your keyboard. Next to a multiply settings, press on the square, which will enable us to sample a color from our plate. Then if you press Ctrl Shift and drag, it's going to sample the average color within the sample box. If we view our grade node, we can see that it's sampled the color and replaced it for the green screen color. This concludes our screen clean section. If we just take this input here and drag it to our new screen clean, we'll be getting what we created. Now that we've completed our screen clean, we can move on to the keying section of our comp. So as I said before in the basic overview, we've got different parts to our keying. We have the garbage mat, the core key, and the edge key. The edge key is our softest key. It's the one which will give us the most accurate edges of our character. Then we have our core key, which will eliminate transparency issues. If you look, we can see transparency issues here with our edge key, and the core key will enable us to fill in these areas. Then we have our garbage mat, which will remove anything around our key which we do not need. So how would we create the edge key? First of all, I would start by creating a key light node, but there are many other keyers you can use. I just find that key light gives me the best results. If we just analyze our setup over here, we can see we have two OCIO color space nodes. In most cases, you might not need this extra setup, but I've introduced this into our keying setup, as sometimes you can achieve a much more accurate edge using the OCIO color space nodes. They enable us to key in a greater range of values by converting the color space to log. I would then create our key in the log space, then convert it back to our original color space. I'm only changing the color space to log for the keying. Let's create this setup together so I can show you what the difference is. In this instance, we won't really notice a big difference because our green screen is pretty good and we're not getting any exposure issues. Let's first start by creating the OCIO color space node by pressing Tab on your keyboard, and then typing OCIO color space, then attach it and double click on it. Change the output properties to log space and attach our key light to our OCIO color space node. Then we can copy the OCIO color space nodes and paste them underneath, and then swap the input and output with this button. Now, in the key light node properties, let's sample our green screen. You can see the grade is desaturated. This is what happens when we look through the OCIO color space node. But this won't affect our keying except make it better. So once you've sampled the green screen under the OCIO color space node, you can then view the results at the end of our setup. It's giving us a nice result. I'm going to sample closer to the neck to get rid of all this excess. Let's create another key light node and sample from exactly the same area. So I'm sampling from this exact same square. You can also press Ctrl Alt because if you don't do that, sometimes you'll alternate between the plate and the alpha. This is just a tip to help. If we compare between our two key light nodes, the only difference between them is that one is using the OCIO setup and the other isn't. If you press A on your keyboard to go back to RGB, we can now compare between the two. Now we can see it's giving us a more accurate edge with the OCIO color space. The key is actually going a bit over, so using OCIO color space will enable the key to get a more accurate edge. It's getting rid of all these areas over here which were too much. Now that that's done, we can move on to this section here. If we look at our edge key over here, you can see we've got transparency issues, which can be solved by using the core key. However, areas which are closer to the border won't be entirely solved by the core key, because if we look over here and deactivate this grade node, we can see that we're still getting transparency issues along the border, as the core key only resolves issues within the character as we're eroding it in. To fix this, we can create a grade node and change the channel to alpha so we're affecting the alpha channel. Then we're reducing the white point, which will increase the values that we have, but also it's bringing more values in our hole, which should be black, so we can reduce our black point in order to get back that hole. Next, we're going to limit this to a specific area, as if we don't, and we deactivate our roto, we can see that our grade node is also affecting other areas of our comp, and these areas we want to keep. We want to keep our smooth edge, so we don't want this to happen. We only want it to affect this section, so that's why we're creating a roto node. If we go back to our roto and press Z while selecting all your 4 points, it will make your shape round. Then let's create a blur node enabling us to smoothen the edges, so we're not getting a harsh edge around the roto. Now if you deactivate our grade nodes and reactivate them, you can see that we're getting a much better result. Now that we have finished with the edge key, we can move on to the core key. Let's make some space in our setup over here so we can recreate it. So let's remind ourselves what a core key is. So the core key is a shrinked key placed on top of our edge key, enabling us to fill in transparency issues or holes. I like to use a Primac keyer to create my core key, but you can use many other keyers. I just find the Primac keyer a lot more intuitive for core keys. If you press Tab on your keyboard and then type Primat, you can select it in the drop down menu. Then let's attach it to our plate. We can switch back to RGB by pressing A on our keyboard while viewing the monitor, and then let's view our Primat node. In the Primat node, you can see the color picker has already been selected, so you just need to press Ctrl and then choose the green screen color. Now if you press A on your keyboard to bring back the alpha, you can see there's loads of residue which we need to remove. We can do this by changing the operation here to clean background noise. And then if you press Ctrl Shift, you can drag over the excess areas. Now if you switch to clean foreground noise, you can drag over the character just to make sure there's no holes in the matte. Then we need to shrink our Primac keyer in order to place it on top of our edge key. To do this, let's create an erode node, so we're shrinking down the matte, and then a blur node to soften the edges. You can do this by pressing B. Now I'm just going to tweak the settings until I find something which works. Then let's create a merge node and attach the B input to our edge key, and then the A input to our core key. Then if we select it and view our merge, we can see that our core key matte is going too far over the edge. Let's adjust the settings of the erode and the blur to fix this. The next step of our keying setup is our garbage mat. It allows us to get rid of any excess bits or pieces that are appearing in our green screen. Like with the core key, the first step is to create an erode node, but then expand it outwards. But as you can see, there's some excess noise from the key, which wasn't visible previously, as they were too small to be noticeable. But now that we're expanding the mat, they are interfering with our key. To fix this, we can erode our garbage mat a little before expanding it. Next, we're going to add a blur node to soften the mat. Lastly, we need to get rid of all the excess around the green screen. To do this, let's create a merge node and stencil out the area which we want to remove. If you press O on your keyboard, you can create a roto node in order to define this area. We also need to switch the inputs as they are wrong. To do this, press Shift X on your keyboard. Now you can start drawing your roto shape. If you select your points and press Z, you'll be able to curve the shape. Let's also soften the mat with a blur. You will also need to animate the roto shape along the sequence as the character changes position during the shot. Now change the merge operation to stencil in order to remove the excess elements from our key. Create a second merge, but this time change the operation to in. This means that it will keep everything from this mat within this mat. If we look at our final results, we can see our garbage mat is removing everything outside of the mat we created. This concludes our keying setup. So I've just cleaned our keying setup over here. Now let's move on to the despill section. If we press A on our keyboard, whilst we hover our mouse over the monitor, we can switch back to RGB. Despilling is the process of removing the green hue reflecting onto our character from the green screen. If we deactivate everything affecting this B pipe, we can see the green hue more clearly. In order to get rid of it, we are going to use a despill. I like to use the key light node as my despill. It is usually used for keying, but it also has a despill built in. To activate the despill, set your color by sampling from the green screen. If we look at our setup, we can see it's removing all the green hue for us. The only downside is that it's also removing the light which is generated from the green hue. When working in the industry, clients often want to keep this. We're losing light here on the jacket and in many other areas. We can retrieve these luminance values by recreating this setup. First off, let's create a merge by pressing M and set the operation to from. The operation allows us to remove the result from here, away from here. This gives us what's missing, which is the green hue. Next, let's create a shuffle node and feed the light lost back into the R, G and B channels. Feeding it into the red and blue channels instead of just the green allows us to change the green hue to a desaturated hue. Let's create another merge, but this time let's set the operation to plus. This operation is useful when bringing back light. If it's too bright, you can add a grade node and lower the gain. Let's now attach it to our setup. The despill is working very well in the center of our character, giving us natural skin tones, but there is still a green hue remaining on the edge of his face. We can fix this by creating a second despill setup. To do this, copy and paste the setup we just made, this time in the key light node settings, press on the alpha bias color picker and then press Ctrl Alt and move left to right until you find a color that works best for the skin tones. This despill is harsher than the first one and we want it to only affect the areas where it's needed. We can limit it through a roto and a key mix. First, let's create a key mix and attach the B to our main despill and then the A to our despill fix. Then, let's create a roto node and then add a blur node. We would also need to animate the roto to make sure the roto is following the character during the sequence. Let's now attach this to our copy and pre-melt node. The copy node is essentially feeding in the alpha from our key into our despilled plate, and then the pre-melt is cutting out the character using the data from the alpha. When looking at our final comp, we can see a bright edge here. We can fix this by reducing our grade node in this section by changing the gain values. We can also limit it to certain sections with a roto node in order to keep the light which has been retrieved. Now that we've finished with our despill section, we can move on to the grading section. Grading ensures that our foreground looks like it belongs with our background. To do this, press G on your keyboard to create a grade node. Then press Ctrl, then click on the highlight here to create a dot. We can now attach our grade to our setup. If we view our comp, we can see our character does not look like it belongs in the footage at the moment. The character is underlit and the colour of the foreground doesn't match with the background. Let's first start by matching the highlights and the darks. You can do this by using the lift and the gain in your grade node. Let's bring up the gain of our character to increase the brightness. Then let's move on to the darks. If we increase our gamma with the viewer sliders, we can see our darks more clearly. When dealing with darks in footage, an important note to remember is that the closer an element is to a camera, the darker the darks are going to be. Whereas elements which are further away from the camera are going to have lighter darks. We can see this very clearly in our backplate. The further we go, the lighter the darks are. So naturally, our foreground character is going to have darker darks than the elements in the background. I'm just going to decrease the lift in the grade node, which will make our darks a little darker. We can see our darks over here have a red tint in comparison to the darks in our character. This is in part justified as the shirt he's wearing is slightly blue, whereas here we have the dirt on the ground, which of course has more of a red tint, but I think in the general sense of the plate, there is a bit more red in the darks. So I'm just going to increase it in our character. If you press Ctrl and click on your colour wheel, this menu will pop up and you can now change different colour sliders with more accuracy. I'm going to increase the reds with my middle mouse button by scrolling up and down. You can also use the arrows on your keyboard or the sliders. This matches pretty well now. I'm also going to bring the viewer slider of the gamma back to its original settings by pressing Ctrl and clicking on the slider with my left mouse button. Now let's adjust the colour of the gain by pressing on the colour wheel. I think the character is slightly too magenta, so I'm decreasing the red. You can also adjust here by dragging the dots along the colour wheel. I am going for more orange tones to match the background. This works quite well. Now that we've finished with the grading, we can move on to the additive keyer section. This is a very important step of keying, especially if your character has a lot of fine detail or hair that we want to preserve. When keying, it is tricky to retrieve all the fine hair details from our green screen. The additive keyer is a solution to this. Essentially, the additive keyer is multiplying our green screen plate back on top of the footage, then adding a transform that I have also added here, because when we look at our footage without the transform node, a character is too small. I've added a transform node to scale up our subject. Then I'm desaturating using a saturation node to eliminate the pink hue from our additive keyer. Next I'm adding a grade node. This will enable us to tweak how much of the additive keyer we want to see. We can do this by adjusting the lift. Lastly, I'm creating a merge node and setting it to multiply as we're multiplying our footage back on top. Now if I start tweaking the lift, we are making our additive keyer stronger or weaker. We can also limit our additive keyer to specific areas using a roto and a grade node. I'm also adding a blur node to smoothen the edges of our roto. Now if you increase the lift and invert it over here, you can limit it to a certain section. So why would we limit our additive keyer? If we take a look at our setup without our grade nodes and look at our final comp, we can see a dark edge is being introduced by our additive keyer. The solution to this is to increase the lift in our grade node, but by doing this we're also reducing all the details we retrieved. That's why we create a second grade node to limit the effect on the additive keyer to only where it's needed. This concludes our section on the additive keyer. Let's move on to the last step, which is our regrain section. We're using a node called DasGrain. This is the way we regrain in most VFX studios in the industry. We usually use DasGrain, but there are many other ways to regrain footage in Nuke. As you can see, DasGrain is connected to many different outputs. We have one input, which is the plate, one input, which is the degrain plate, then the comp, and finally a mask input, which is attached to a difference node. The difference node is generating a mask for us, allowing us to only add grain in areas which were modified in the comp, but keep the original grain in areas unaffected. We are also using postage stamps instead of copying and pasting read nodes. This keeps our script light and neat by avoiding duplicate read nodes. It also enables reading the nodes without requiring connections to travel all the way to the top of our node graph. If you press Tab on your keyboard and then type postage stamp, it should appear in your drop-down menu. Once created, select it, then shift select the read node you want to display through it, and press Y on your keyboard. This will connect the two nodes together. This shortcut allows you to save time instead of having to drag the input all the way up to the top of your script. Then check the hide box in the postage stamp properties, making your script tidier. Now let's go to our DasGrain node properties. This defines the number of frames DasGrain is going to analyze the plate with. You can increase the sample count if you want. I usually leave everything on default as it works just fine without any adjustments. If you want to learn more about all the knobs and settings in DasGrain, there are many good tutorials online. Press Analyze, and once DasGrain has finished calculating, compare between the comp without the regrain and with. If we zoom in and lower the gamma in our viewer, we can observe the difference. We're bringing back the grain. It's very subtle as the plate didn't have much grain to start with. There is also a better way to check the grain. I use a tool called QC Technical. You can download it for free on Nukepedia. This tool is used by many of the studios I've worked for. You can also see more clearly what your grain looks like. If we compare our comp, which is denoid, to our comp, which is regrained, you can see we are retrieving all the original grain, but you can also see we're retrieving information which we don't want, such as the green screen and some of the crew. To fix this issue, navigate to your DasGrain properties, and in the Replace tab you can check the Activate Scatter box. This will tell the DasGrain not to use the original grain but to generate its own from the sample box, which we need to define. We're going to sample from the same place as our denoise. Once defined, DasGrain will automatically update the noise. Our viewer is showing our final comp, but DasGrain is automatically sampling from our plate. We have now completed the last step of our keying setup. I hope you enjoyed this video, and please check out our Foundry Learn page for more tutorials.